Alright, so the problem we're doing today is we're trying to give in the derivative, find out what the original function is. So one way of doing that is by using something called a slope field. What you can do is you know that y prime will give you the slope of the original function y. So if you pick just any value on a graph, we started with 0, plug it in, you'll get the output will be the slope of the original. So we pick 0. 0 squared is 0, plus 1 gives you 1 over 1. So that you know that the slope at 0 of the original function is going to be 1. So we drew that in because we don't know where the original function is going to start, but we know that the slope at 0 is 1. So now we're just continuing that process. We go over to 1, we plug that in to the original equation. 1 squared is 1, plus 1, that gives us a slope of 1/2. So then you go in and you draw in a bunch of little slopes of 1/2. And we can do the same for -1. -1 squared is 1, plus 1 gives you a slope of 1/2. If you keep doing that for a bunch of values at x, 0, 1, 2, 3, etc., you're going to get kind of a picture of what the graph of the function might look like. Once you do it enough times, you can pick an y value to start. Say we start here. And you can follow the slope lines and start to create a picture of what this graph might look like. If you draw your slope field accurately enough, you can create a pretty good picture, we're looking at the red line now, of what the graph might look like. And if you draw a good enough picture, you are often able to recognize what that function is. So if we look at this function, it looks a lot like the inverse tangent of x. And if you go backwards to get the inverse of the inverse, you can see that this looks exactly like the tangent of x with a slope of 1 at 0 going up to an undefined slope. And those are reflected over the line x equals 1, and it looks like we've pretty accurately found our antiderivative of our original equation, which was 1 over x squared plus 1.